Hello, my name is Sean McDonald. I am a senior mechanical designer with WFT Engineering in Rockville, Maryland. I specialize in commercial office interior design. As we noted in our previous video on bipolar ionization, according to the EPA, roughly 50% of global illness is caused by indoor air pollution. We spend nearly 90% of our lives in the built environment. In a typical office, air is recirculated through the HVAC system every 7.5 to 10 minutes. This recirculation process provides an excellent opportunity to kill viruses and other airborne contaminants before they spread. Today, I'm going to spend a few minutes discussing ultraviolet germicidal irradiation, commonly referred to as UVGI. UVGI is a method of disinfection that uses short wavelength ultraviolet light, specifically UVC, to inactivate or kill microorganisms such as COVID-19. As you can see, ultraviolet light is divided into 4 categories. UVA and UVB reach the surface of the earth and are the cause of premature skin aging and skin cancers. UVC is completely filtered out by the ozone layer and does not pose a threat when people are exposed to the sun. 254 nanometers is the most lethal wavelength against microorganisms. The most common use of UVC in HVAC systems is at the cooling coils located inside an air handling unit. The UVC irradiation eliminates airborne microorganisms, preventing them from spreading throughout a building. It also prevents the buildup of organic materials on coils, drain pans, and the interior surfaces of the air handling unit. Clean coils greatly increase the efficiency of HVAC systems and therefore can reduce operating costs. I should note that the effectiveness of UVC at killing viruses is a product of time and intensity, both of which are optimal when used inside of an air handling unit. Another option is to use UVC inside of air distribution systems. This solution must evaluate the velocity and temperature of the airflow as they are critical in determining the correct dose of UVC. Another means of utilizing UVC is by using light fixtures that target the upper part of a room. This solution is referred to as upper air or upper room UVC systems. These systems are designed to focus the UVC light in the upper part of the room, thus inactivating airborne infectious agents in the upper part of the room that reach the lighted zone. The lower part of the room is kept relatively UVC free, minimizing exposure to persons in the lower part of the room. Upper air UVC is predominantly used in healthcare settings. There are lighting manufacturers currently researching and developing pendant-type light fixtures that will be capable of providing UVC to the upper air and white light to the lower portion of the room. There is also development of light fixtures that provide UVC to the lower portion of the room when a room is unoccupied. These types of light fixtures would include sensors capable of turning off the fixture if people are detected. Some other options for using UVC are handheld wands and mobile devices. The mobile devices are most commonly used in hospital patient rooms when unoccupied. I would be remiss if I didn't mention that there are risks associated with human exposure to UVC. Effects on the human body vary depending on the amount of exposure, but UVC is a known carcinogen for human skin. It can also cause painful burns on skin and temporary damage to the cornea if observed directly. It is important to consult with a design professional for proper sizing and implementation of UVC to reduce the risk of human exposure as much as possible. In closing, the use of UVC in HVAC systems was heavily promoted in the mid-1990s as a means of improving air quality, but the technology was and still is often misunderstood and underutilized. COVID-19 has certainly renewed interest in the use of UVC. Please don't hesitate to contact WFT Engineering if you are interested in implementing the use of UVC and other strategies to mitigate the health risks associated with COVID-19. Thank you for your time. Be safe. Stay well.